Hello, so let's say you have fencing to be done on two sides of a rectangular corner of a lot, and you have two sides that are free, and you want to do a rectangular lot for a garden. And to isolate this part of the garden that's going to be this inside from the rest of the lot, you're going to use a fencing made of wire of size D, and you're asked to maximize the area. This is from a series of small optimization problems, uh, which are maximization of areas under a certain perimeter. This is one of the simplest versions of them, and in fact uses something that reminisces you of a hyperbola. Just a sec. And the area in here is going to be the area of a rectangle in terms of x and y. So let's say this is the x-axis and this is the y-axis. And you have that the fence has size x plus y is equal d, so it's only those two lengths here. When some they give you d. And since d is constant, we can express y in terms of x. Yes, I forgot placing the x before. D minus x. So let's go close. So the area can be rewritten as x times d minus x, since we can express y in terms of d minus x, giving us dx minus x squared. So how do we maximize? We derive an equal to 0. So we have d minus 2x, which gives us that x is going to be d divided by 2. And so the total area is going to be d squared divided by 4. And is this a maximum? Yes, it is a maximum. The curvature in the point of our solution, and in any point, in fact, it's going to be minus 2, which is smaller than 0, so this is a maximum. And from drawing the function, you would discover that. And by the way, you would discover what was the solution, because it is a parabola, so it has to be symmetric relative to the two roots, which would give you the solution instantly, but we used calculus as it was possible. That's it, bye for now.